Alrighty, we're right at the top of the hour, so we'll go ahead and kick it off. Thank you so much for joining us today, whether on Zoom or Facebook Live, for this Fire Adapted Communities Learning Network webinar on smoke outlooks, education, and awareness. My name is Rachel Bean. I work with the Forest Stewards Guild and will be moderating this session today. So I'm going to introduce Kerry Jones, our presenter today. Kerry attended New Mexico State University before transferring to University of Oklahoma to graduate with a Bachelor's of Science in Meteorology. Oh, and my apologies, I just lost my screen. Okay. He went on to work for the National Oceanic and Atmospheric Administration in a number of positions, including meteorologist intern, general forecaster, and senior forecaster, before receiving his master's in water resources from University of New Mexico in 2006. Staying with NOAA, Kerry took the position of warning coordination meteorologist and then meteorologist in charge after completing his master's, before getting hired on by the U.S. Forest Service in 2021 as the Air and Water Quality Specialist and Liaison to the New Mexico Environment Department. In his current capacity, Kerry focuses on air quality and fire season forecasting. We're happy to have him with us here today, and with that, I'll turn it over to you, Kerry.
And I would, just like to take a few seconds to thank Gabe and Rachel for this opportunity to speak with you this afternoon. So I thought we would take some time today to talk about smoke. And I'm certainly, while new to the Forest Service, have been involved with fire weather, various fire weather related activities through a good part of my career. The one thing that I would add is that early in my career, I was an incident meteorologist, which are specialized kind of technical positions within a wildfire, especially with teams that fight our wildfires. So I do have that experience. And as an air resource advisor, which I am also a newly minted air resource advisor, it's very similar to an IMET position, only rather than focusing strictly on weather, as IMETs do, an air resource advisor focuses on smoke impacts, with a special emphasis on the communities that are impacted and the broader general public. So we'll talk a little bit about smoke. I'm certainly not, I don't consider myself an expert by any stretch in smoke, but I will definitely share some important characteristics that we want to understand, some health impacts considerations, and then I think, as Gabe alluded to, both on the monitoring side as well as how we look in terms of forecasting smoke impacts. So that's kind of what our outline is for this presentation. And obviously concerns about smoke are wide-ranging. Top among those on the list would be the health impacts, both for public as well as our frontline firefighters and fireline workers. Safety, of course, when it comes to smoke, and when you think of safety, I'm sure a lot of things might come to mind. I would throw out there certainly road impacts, and certainly with safety and the liability that would come with that. We haven't, or at least in my experience, haven't experienced that too much, but here, just in the news very recently in the state of Florida with super fog, which is kind of related to smoke in certain conditions, smoke-induced fog, and the impacts that it can have on highways. And then, of course, as we go down the list here, visibility, which is obviously a big and important consideration in New Mexico. Nuisance smoke is smoke that doesn't quite or doesn't violate federal standards for clean air, but still nonetheless provides impacts. And then as well, social and even impacts to wildlife that perhaps we don't think much about or enough about. So let me just kind of set the stage that in 1970, the Clean Air Act was passed. It went through major amendments in 1977 and 1990. And it's Section 109 of the Clean Air Act that requires the EPA to create primary air pollutant standards that protect human health, as well as secondary standards that protect human welfare as well as the environment. And so with that, or I should say from the Clean Air Act, we have what we call National Ambient Air Quality Standards. That's known as NAAQS, which is the acronym. And NAAQS, these primary and secondary air quality standards are what we refer to as the NAAQS. And so if you hear that referenced, for example, a 24 average for particulate matter has to be below a certain threshold, or there's implications for that. So within NAAQS, there are criteria pollutants, and the chief among those, carbon monoxide, CO, particulate matter, which is what we're going to focus on. And if I do reference PM interchangeably with particulate matter, we'll talk more about that in just a moment. Ozone is also a criteria pollutant, as is nitrogen oxide and nitrogen dioxide. So together, we sometimes will use NOx as kind of an abbreviation of that. So the key criteria pollutants that are generated by fire, those ones that are highlighted there, but really it's carbon monoxide and it's PM that is of most concern. Arguably, obviously, the particulate matter is kind of what we're focused on. So when it comes to PM or particulate matter, in terms of what we call an emission factor, so this would be how much particulate matter is released by consuming X, or in this case, 1 ton of fuel. So you'll see that it's a pretty good range, varying from, on the low end, 10 pounds per ton, to the high end, perhaps closer to 100 pounds per ton. And really that range depends on, are we in a smoldering environment, or are we in kind of active fire, like active flame, which actually produces less PM on average. And again, it is a criteria pollutant, but PM, particulate matter, does have direct effects on human health, of course, as well as welfare. And as I mentioned earlier, adverse impacts for not only the public, the general public, but for fire line workers. That's also a big concern. Smoke is known to carry carcinogenic compounds, as well as impair visibility. And when we talk about visibility impairment, regional haze, that's also an important consideration when it comes to understanding and also monitoring for particulate matter. So what are some takeaways here, kind of the skinny on smoke? Smoke emissions from fires, be it wildfire or prescribed fire, are generally known to be about 90% carbon dioxide and water vapor. So carbon dioxide, CO2, is the largest single emission, but it's also a very important greenhouse gas, as we all know. So 90% of smoke is CO2 and water vapor. The remaining 10% consists of other not so good compounds, to include carbon monoxide, which again is a criteria pollutant that I mentioned. Hydrocarbons, an example of a hydrocarbon would be methane, nitrogen oxides, and then, of course, particulate matter. So it's kind of interesting when you think about the breakdown, and specifically talking about PM, that's only about, a tenth, maybe 10% of what is comprised of smoke emissions. And of the PM, of the particulate matter, 70% are less than 2.5 microns or micrometers in diameter. So extremely tiny particles. And PM2, and so you'll hear referenced PM 2.5, and that's exactly what we're referring to, is that those very tiny particulates. The other, I think, criteria pollutant that I mentioned was ozone. And ozone is considered a secondary pollutant because it requires two primary pollutants to be together in a very favorable situation for ozone to actually form. But wildland fires do produce nitrogen oxides, as I mentioned earlier, 90% nitrogen oxides, that's NO, and then about 10% nitrogen dioxide, NO2. So in the presence of sunlight, oxygen reacts with these nitrogen oxides and also VOCs, which we know as volatile organic compounds, and will produce ozone at near surface level. Of course, ozone in the stratosphere, that's where we want it. That's a good thing. But ozone, where we live and breathe the air, is not good, and it's harmful. And so wildfire and prescribed fire smoke, there is obviously concerns with ozone production in certain cases. And again, it has to be a pretty ideal situation for that to play out. So I mentioned that about 70% of smoke particles from wood that's the tiny particles. PM 2.5 is about 70% of that. And so the remaining is kind of larger diameter particulate matter, PM 10, and then kind of something in between would be about 20%. So the PM 2.5 and smaller particulate matter is of concern because that's really where we get into kind of the health related impacts. And so just as kind of a reference scale, PM 2.5 is about 35 times smaller than your average human hair. So very, very tiny. And those very tiny particles are carried very deep within lung tissue. And that's really where, the concern comes from. So obviously we have aggravation of respiratory or cardiovascular illness when you're in the presence of very high concentrations of PM 2.5, lung function issues, just increased work loss for folks. And so it can have some pretty significant health impacts when you're in an environment, again, with very high concentrations of not only PM 2.5, but PM 10 as well. PM 10 would be close, we talk about pollen would be in that category, but more importantly for us in the Southwest, dust. So here's kind of another kind of graph just to show that, and again, not being a medical doctor or a health professional, this is just, what we know and what we've learned is that PM 2.5 deep into the lung tissue with the, I know I was gonna mess that up, alveoli, right, which are the the air sacs within your lungs. And so these fine particulates can get in and damage or otherwise, change the function of your respiratory system. So yeah, I kind of fumbled through that. You can tell I'm not a medical professional, but you can certainly imagine that. And I think the one thing I like about this graph is that, roughly, I've heard it described that, your nose is kind of your natural air filter, right? And I think we've all kind of experienced that. And we're into the season now where juniper pollen and other allergens are affecting many of us. So generally at that level, the coarser particles, so like the PM10 and larger, are filtered out when you breathe the air in. But if it's coming through like your mouth and you're talking about PM 2.5, real tiny particles, that's what gets down deep into the lung tissue and creates the concern. So I think we can all appreciate and understand that being in very high concentrations of PM 2.5 is not healthy. So I guess with that in mind, let's talk a little bit about how we monitor smoke. And so there are permanent stations within New Mexico that provide measurements of PM 2.5 as well as PM 10. The image you see here is a station that was actually up. There's actually two separate photos there. The larger image is from an air quality monitor that was up in Idaho on a wildfire that I was supporting back in September of last year. The inset image is kind of the same monitor in New Mexico that we had set up along. I think that was actually outside of where was it? I think that was north of Las Vegas, if I remember correctly. But these are portable monitors, and so we're able to take these into communities or locations where we anticipate high concentrations of smoke. And so we can set these up and run them weeks on end without any major issues. And so the example that you see here, it uses what we call near forward light scattering technology. So that there's a pump and it draws in air into the unit. And there's kind of what we call a sharp cyclone that separates out the particles. And then using that near forward light scattering technology will give us an estimate of the concentration of PM 2.5. And so with that, we're able to pretty accurately tell how much smoke is in the air hour by hour over the course of days, if not weeks. So here's an example of what that might look like. And this is just a collection. We have over a dozen of these monitors within New Mexico that are portable and can be deployed. And last year, with our fires, we deployed every single one that we had at our disposal. There's also a cache, a national cache of monitors up in the Denver area, so that in cases where we need more, we can actually get those on site and set up. So this just kind of gives you an example of where we had monitors set up. And a lot of these are pretty small communities, places like Winston, New Mexico, Hillsboro, outside of Caballo. So we can pretty accurately tell, how smoke is not only behaving, but kind of moving into and out of certain areas and how those concentrations look over time. So this is an example, as I said, from the Black Fire. This next slide will give you an example. I was supporting this fire up in central Idaho, and it's been a while, but back in September, I, was in a scenario where we had very unhealthy, if not hazardous, air quality for over 24 hours. And that's what you see by these kind of deep purple bars here, back in September of last year. And, just using photo monitoring or photo trends, has been a big part of monitoring smoke, whether it's webcams or photo cameras, I should say. But you can see here just kind of an example where that top image is kind of a reasonably good day, or what would be considered, good, maybe kind of low and moderate, but generally good air quality on that top image. Whereas the bottom image was taken the same day that we kind of spiked out in very unhealthy air quality. So these monitors are very high tech, and they do provide us lots of great information. Of course, the one drawback is it's only as good as the location that we cite it, and it may or may not be representative of a broader area. Just like we know in terms of weather stations and monitoring, things can be very different over short distances. So my introduction to smoke while I was with NOAA was back actually in 2011. And I'm sure there were other cases prior, but 2011 was a really interesting, from an public impact standpoint. About 3 weeks prior to Los Conchas wildfire in June of 2011, the Wallow fire in eastern Arizona sent smoke plumes into New Mexico with significant impact for Albuquerque, Santa Fe, and all of our wonderful communities farther to the west and southwest. And we also had other fires down in southeastern Arizona that were sending smoke. And when we talk about smoke and air quality, we talk about air sheds, very similar to how you would describe a watershed. Air sheds are very large, and when you put enough smoke in the air shed to the point where it can't take any more smoke, we start to have big issues. And so early June of 2011 was one of those times. And I live east of Albuquerque, and I remember this event very clearly because I was going to work, working an overnight shift during that time, and I came out to ash covering my windshield. And my first reaction was, I thought there was the fire must have been just very close to my location, when in fact it was hundreds of miles away. So when we talk about wildfire smoke, I think it's important that we understand that wildfire smoke has far-reaching implications. If I had a satellite image, I could zoom out and show you that this smoke had impacts over the Midwest, and actually, states even farther east. So it's not just New Mexico, Arizona, the Southwest, far-reaching when it comes to these very large wildfires. And so we had efforts back in 2011, over a decade ago, to try and paint where we thought impacts would be the most significant. And this was done through a combination of using the smoke models that have advanced considerably in the last 10 years, but also just using our monitor network and trying to get the best information out to the public so that they can plan ahead. So when we forecast smoke, I mentioned Air Resource Advisor, which is an interagency program that includes all different agencies that are involved. And so you go through training, and when you go to a wildfire incident, you provide information geared towards the general public. And so this isn't necessarily, while it is directed for the teams that fight wildfires, the primary audience, again, is the general public, which, schools would be a good example, hospitals, and just overall communities that are impacted. So we use different types of modeling. I don't want to get too into the weeds on smoke modeling per se, but we have pretty simple systems. You may be familiar with ventilation, or you've heard the term ventilation or ventilation index. That's information that you can get from the National Weather Service on a daily basis for any number of geographic areas in New Mexico. That'll provide you with the number of hours that ventilation is expected to be not poor, or just in general kind of trends in terms of days where ventilation will be good, days where ventilation not so good. And then we use dispersion modeling, so that provides us with detailed information on concentrations of smoke and where that highest concentration of smoke will end up. And I think on this next image, hopefully that's an animation. There's two animations on this screen. I apologize. I'll let your eyes adjust. But this just kind of gives you an example of one model that we use pretty extensively to give us information in terms of smoke concentrations, as well as where smoke is going to end up. And these models are sometimes very, very good. And yeah, sometimes not so much, right? Depending on how well they're initialized and how well they just kind of capture the overall atmospheric conditions. So, but this is an example of how we might use a model to perhaps alert folks well away from the actual wildfires in terms of increasing smoke impacts. And so this is again back in April, the end of April of last year. So what we do with this, and we coordinate, this is obviously not done in a vacuum. We have a team that includes the State Department of Environment, Department of Health, our National Weather Service partners. And so we kind of all get together and discuss the models, discuss where we think the greatest impacts are going to be, as well as the monitoring information. And we generate air quality alerts. So air quality alerts are issued by the National Weather Service. They are, on my next slide, I'll show you, but they're issued by geographic zone. And so decisions are made to include or not include a zone based on what we're seeing in the modeling data. Last year, 2022, we issued the greatest number of AQAs for smoke in New Mexico since we formally established those back in 2011. And again, that was during that Wallow event. And since then, you can see the list there that we've had impacts. But as you see there on the bar chart, really since 2011 and to a lesser extent 2012, which was kind of Whitewater, Baldy, Little Bear, some other big fires in the state, we didn't have too many significant impacts from wildfire smoke up until last year. And so I think if you're new to the state or it had been a while since you had seen those air quality alerts show up in the various media outlets, that's kind of the reason why. And so there's just kind of some maps that I pulled together just to show that there were areas in San Miguel, in Mora counties, where we had close to 27, 28 consecutive days where we had air quality alerts in effect. And so, and we had 13 consecutive days just in the Espanola Valley, to include up in the Santa Fe area. So again, pretty significant to think about, again, getting back to the health impacts and being exposed to high concentrations of PM 2.5 day after day after day. So, and I believe I have a couple more slides, and then we'll certainly open it up to questions. The one thing that I'm, I guess, as a meteorologist and really trying to better understand the impacts of smoke, how to help you all plan, we're trying to drill down and find those patterns where, if we have smoke in certain areas, and this is just one example for Santa Fe, you could do this for any number of communities, is trying to better understand the weather, the very small scale weather patterns that would tend to favor high concentrations of smoke in the Santa Fe area in this example, and then trying to do a better job when it comes to forecasting those impacts, so that if we do anticipate a day where you see like a red bar on this chart, you can make alternate plans. Maybe it's a trip to Albuquerque, or maybe it's time to consider some sort of you can buy like the DYI filtration, like a HEPA filter setup, things like that. And if we're able to forecast, maybe not days in advance, but a half day, 12, 24 hours, something like that, that would go a long ways, I think, in helping mitigate the impacts of smoke. So I think with that, I'm going to end on the official outlook, because actually that just came out today, March 16th. It's the third Thursday of every month. We get fresh outlooks from our NOAA colleagues. And so the images on the top are for temperature outlooks as we go through the remainder of spring into summer. And you can see the signal is, despite the kind of recent week or two of wet and cool for parts of New Mexico, The overall signal is above average on temperatures as we go through spring, the remainder of spring into summer. And then you'll see at the bottom, those are the precip outlooks. And for April, still kind of odds tilted towards below average precip as we get into April and May. But then notice kind of as we go into May, June, we think that that dry signal will start to fade away. And so I think the good news that we don't anticipate certainly a repeat of what we had in 2022. It's hard to imagine having anything close to that from what we experienced. And when you look at the significant fire potential outlook for the next several months, outside of some of our low elevation areas in eastern New Mexico, especially the southeastern part of the state, the middle and lower Rio Grande Valley, kind of along the Bosque, where we certainly have some concern for the next couple of months, as Gabe alluded to, kind of warmer and drier days. It only takes a few of those back to back to really change things around. But you'll notice as we get into the heart of our fire season, May and June, that we don't have any area highlighted for above normal, which is certainly a favorable trend and something that we didn't see last year at this time. And in fact, if you look closely, you'll see a couple areas out in northern Arizona, the Maguio and Rim, perhaps below normal for the first time in a couple, 3 seasons. So some good news there. But nonetheless, fire season is close to being on us here, and we still have several more weeks potentially to dry things out and to have some concern in terms of kind of mid or lower elevation areas where we can have some range fires, grass fires that can produce smoke and have some smoke impacts. So with that, my email, and if I'll go ahead and stop sharing, I believe, and do my best to take any questions.
Great. Thank you so much for the wonderful presentation, Kerry. We really appreciate it. So we'll go ahead and kick it off with a question from Sandy Herlocker, who asked, how reliable are the purple air monitors for augmenting the official monitors, and or where do they fit into our broader smoke forecasting toolkit?
Thanks, Sandy. And I like the purple airs for a couple of reasons. So let me first say that the purple air is a low-cost air quality monitor. It's literally the size of a softball. I've used them and have installed them. And so they can be both indoors and outdoors. Becoming more popular, I should say. I think there's over a dozen in Santa Fe, and even in the kind of the area where I live, there's several that are installed. So these are low-cost sensors, just over $200, kind of on the low end. There's different levels you can get. So the one thing that I like about purple air monitors is you see the trends very well. And you can go to purpleair.com, and there's a nice, you can see the map. These purple air sensors are also ingested or included in the Fire the Air Now, the smoke map that's often shared widely during fire season. So whenever you see smoke that kind of moves into an area or maybe fills up a valley and starts to move around, if you have a sufficient number of purple airs, you will see those kind of real-time spikes because they are real-time. So unlike the monitors that I shared, which only provide you can change it, but generally those are, the standard is 1 hour. So you get a readout every hour. And so sometimes things can change quite a bit within that hour. And having these purple airs in these areas, you can see how the smoke is moving and interacting with certain terrain features and that sort of thing. So we do use them extensively. And in fact, when I was on a fire in September of last year, we installed 2 of them ourselves. The one thing they do require is a Wi-Fi. So they do need an internet connection with kind of a Wi-Fi, home Wi-Fi as kind of an example, whatever, you know what I'm saying, with Wi-Fi. So, but yeah, and I know they're becoming more and more popular. I was telling Gabe earlier that I know of some Western states that are purchasing Purple Air units for schools to install. I saw a story, I believe it was on a national, news program where a science teacher was using Purple Airs to kind of teach students about air quality and also kind of data, because you can have, you have access to a pretty good data set. So.
Great. And just so everyone is aware, Gabe did post a link to the Purple Air network in the chat, so you can check that out. So Mike mentioned that, like many folks in his community, he sleeps with the windows open during fire season. So if you wake up smelling smoke, what do you do, knowing that it could be a neighbor's barbecue, smoke blowing in from a large fire over state lines, or a wildfire just up the road from you?
Well, I think the first thing, thanks for the question. I mean, my first reaction to that is, let's understand, and hopefully, I guess there's maybe some situational awareness in terms of if there's active wildfires, or if it's a prescribed fire scenario, that we're aware at least of what's kind of going on in the immediate area. But if it's more of one of those, wow, I was not expecting this scenario, then I think there's a couple of things that I would do. I would certainly verify using any number of, and I think, Gabe, if you can throw that in chat, the fire.airnow.gov site is kind of a go-to resource in terms of the monitoring piece. And it will also show projected concentrations in smoke plumes as well, kind of plotted. Once we get into fire season, they'll have that information on there as well. So I would say verify kind of the source, and then understand the concentrations. I know in New Mexico, we rely on the 531, so where your eyes are your best tools. So generally, visibility that's less than 5 miles. So if you have a marker, like a geographic marker where you live, and the visibility is less than 5 miles, then you're getting into potentially unhealthy air quality. And certainly as you get under 3 and especially 1 mile, you're definitely within the the unhealthy range. So that might be a couple of my suggested actions at that point. And then, from there, it's just more of air filtration, avoiding as much of that as possible. So closing windows, and not, for those that have evaporative coolers, kind of minimizing use of bringing that outside air, degraded air, inside. So that's kind of what you want to avoid.
So sort of feeding off of that question, Priscilla asked how poor AQI is communicated to the public, and at which levels, 1 through 6, in the AQI do you advise the public to take action? So this might be a great time to talk about air quality alerts.
Okay. So generally, so let me back up a little bit. I should have put that in my slide. So when the Weather Service issues an air quality alert based on guidance from our coordination team, we're generally focused on the unhealthy for sensitive groups in terms of that AQI category. And then from there, unhealthy, very unhealthy, hazardous. So any of those levels, if we think the impacts of USG, we call it unhealthy for sensitive groups, is going to cover a big enough area of the zone, then we would recommend issuing those air quality alerts. So I think did I understand that question correctly though? Is that, or was it more in terms of that the AQI is not well known, or it needs to be better communicated, publicized during fire season?
Yeah, and I think it's also how folks can get alerts in real time.
Oh, okay, yeah. So the best thing, I think the AQAs that in New Mexico, now every state's a little bit different. You know, for example, I know in Arizona, I believe that the state Department of Environmental Quality has, I believe, a phone app or some sort of email system that you can subscribe to. In New Mexico, we don't have that. But what we do have is a very robust coordination group. And so those AQAs, those air quality alerts, are generally very accessible. And I believe you can, I would have to get further information on that, but I do believe you can sign up through National Weather Service to receive that. It's like an email, phone, that sort of thing. But in any case, those are generally pretty widely distributed through media outlets, of course, on the web. And that's kind of your best source in terms of getting that information. And as I said, we're generally focused on the unhealthy for sensitive groups. So that would be like AQA values that get up generally above, if you're familiar with the index, the AQI, above 100. And then from there, yeah, I mean, the recommended actions or what we would suggest kind of scale based on how high that value can get. So in some cases, if you're in hazardous, very unhealthy or hazardous air quality, the AQI index, then basically everyone is going to be at risk of impacts, health impacts. So you definitely want to eliminate, significantly reduce time outside.
Okay, thank you. And Priscilla and Stace, if you guys have any additional follow-up on those questions, please feel free to unmute and ask if you would like to. So moving down the line a little bit, I'm wondering, oh, go ahead, Stace.
I'll just apologize for the quality of my voice. I'm getting over the Kraken variant of COVID at the moment. Kerry, thanks for a great presentation and for the suggestion to look for alerts from the National Weather Service. I was just on their site and they say that they do not provide alerts to the general public. So does anybody on this call have any ideas on how ordinary citizens like me, I have lung disease anyway, can get alerted when the air quality index is approaching levels that might be dangerous for people with health conditions?
Let me check.
And I'll just interject, I don't want to derail the call here. So if there's the opportunity to provide this information to those of us later when you send out the recording, I'm fine with that. But please know that many of us would love to have a little advance notice, and turning on the evening news might not be the best way to get it.
Understood. Yeah. I need to check though. There might be, so the AQA is a product that I might be misinformed that on the automatic notification, because I believe there is a way through. Now, the other thing too, and are you in Santa Fe County?
Yes, I am. I'm in El Dorado at Santa Fe.
Okay. So I would say that, individual counties also have different ways of pushing out, push notification. And so there might be something to explore through the county. I need to do a little homework on that, but I will definitely follow up. So, and I would agree 100% that it's, this is it would be a very important resource to have that notification. So, but just know that the AQAs are issued well in advance. Generally, we try to do 12 to 24 hours type notice. And so if that's something that we need to work on in terms of getting the push notification issue resolved, I'll make note of that.
And a few folks did drop things in the chat. So a couple of my colleagues mentioned that Alert Santa Fe is a good resource for folks who are here in the county. And then a colleague of mine up in the Pacific Northwest mentions that they use Air Visual, which will alert you of a high AQI level in your area. So those are both things that people can look into. So moving forward, can you discuss some of the trade-offs between prescribed fire smoke and wildfire smoke?
Yes, and thanks for that question. I think, as I mentioned, we need, when we think regionally or certainly beyond kind of state level, the impacts of wildfire smoke are well documented to extend and impact areas far, hundreds of miles away from the actual fire. So, I mean, we've seen that over and over. Particularly last year, we saw those impacts. Generally, with smoke from a prescribed fire, you're talking about more localized impacts, shorter duration, and generally, just less intense. That's always probably an important distinction. Understanding what we went through in 2022, but I think that's probably the biggest important distinction, is that wildfires, almost without exception, I shouldn't say that, maybe with a few exceptions, but wildfire smoke tends to have much more regional, broader impacts than does prescribed fire.
Great, thank you for the summary. Alrighty, so I only have a couple more questions for you. So if anyone has additional questions and wants to drop them into the chat, please feel free. I was wondering, how are fire and air quality managers using locally sourced data to complement broader forecasting tools? And you talked about this a little bit, but looking beyond RAWs and portable air monitors.
In terms of smoke specifically, or just broadly the monitoring piece?
Just broader, any kind of forecasting.
Yeah, so, forecasting, as I said, there's let me step back. So in terms of the actual monitoring, we talked a little bit about the portable monitors that we have for smoke. RAWs are remote automated weather stations, and there's dozens of those across New Mexico that are maintained by federal land management agencies, owned and maintained. And then, of course, we have other networks. The state of New Mexico, their network is expanding here in the next 2 to 3 years. So we're going to have, at least from where we're at today, kind of a denser network of weather observations. And with that denser network of observations, you naturally improve forecasting. And when I say naturally, what I mean by that is through observation, being able to kind of understand the microclimates that we have in New Mexico, and being able to apply ever more accurate forecasting and models to kind of the day-to-day weather forecasts. So, I think in terms of how is all this integrated and how do we take advantage of it, is probably, I guess, in the coming months and years, we'll get eventually probably better connected to that information kind of on a daily basis, so we're not as isolated. And in terms of, in my position, kind of being a little bit of a liaison role, not only with the state, but also with NOAA, with Weather Service, and being able to put the time and effort into forecast at a very local scale, which is more than just kind of going and clicking on a point, but it's actually it's on site. It's being present and understanding the effects of terrain and the effects of, having those extra weather stations and the data to be able to kind of integrate all that into a very detailed forecast. So I think that is the future. And I see some great advances in that area in the coming years, actually. So it's kind of exciting work.
Thank you, Kerry. So we're getting towards the end of the hour here. We'll just cover one or two more quick questions. Martha was wondering, do the characteristics of smoke change with different intensities of wildfire or what is burning?
Yeah, it's a great question. I'm not sure I don't know that I am well versed enough to maybe answer that to any degree of satisfaction, other than the fact that, yeah, obviously what's burning has a huge impact. How much of the fuel is consumed is a huge part of that. I think I mentioned that those emission factors, whether you're an active fire or if it's kind of more smoldering, has huge impacts in terms of the emissions. And so I think that's why it's so critically important that you're trying to find these windows or these periods in time where you want to have the effects, the positive effects, and sometimes looking for those windows becomes harder and harder. But it definitely does impact in terms of the emissions, in terms of the different fuel types and so forth. So yes, I mean, there's definitely it's factored in. In fact, one of the models that I didn't show in my slides that we use extensively, allows me to go in and make some of those adjustments in terms of different fuel types, how much of that fuel is being consumed, things like that. So yes.
And I imagine that most folks on the call are aware of this, but when we talk about fuel, we're talking about usually organic flammable materials. So, all right. Well, I really appreciate everyone's interaction on this webinar today. And I'll go ahead and turn it back over to my colleague, Gabe, before we finish out. But thank you so much for being here, Kerry. I really appreciate it.
Thank you for having me.
I just want to thank Kerry again and thank Rachel for moderating and all of you for being on today. I hope you all have a good rest of your day.